Welcome, everyone. This is HDIN Research's 2026 deep dive into the global reusable launch vehicle landscape. We are currently witnessing the most significant shift in aerospace since the Apollo era. This isn't just about rockets. It's about the industrialization of Earth's orbit and the strategic agility required to survive in the new space economy. The bottom line is this: space access is no longer a scientific frontier. It is a high-stakes logistics race. National sovereignty now depends on turnaround time. At HDIN, we've identified a massive pivot toward methalox propulsion and stainless steel structures as the definitive winning formula for the 2030 horizon. To understand the economics, we must look at the hardware. By recovering the first stage, we are effectively salvaging nearly 80% of the vehicle's capital value. Our research emphasizes that reusability is only half the battle. The true competitive advantage lies in rapid turnaround and mass production, moving away from bespoke engineering toward an airline-style operation. The demand side is staggering. As you can see on this chart, we project over 100,000 active nodes in LEO by 2030. This growth is driven by massive sovereign projects like China's GW and Xianfan constellations. Without high-cadence reusable launchers, this growth curve simply becomes physically and financially impossible to maintain. This is the moat slide. Look at the gap between legacy expendable rockets at over $9,000 per kilo and the Starship projection of $100. SpaceX has effectively created a cost barrier that threatens to monopolize orbital access. For any competitor, reaching the $2,000 to $3,000 range isn't just a goal, it's a survival requirement. This leads us to the central question of our study. How do other nations and commercial players break this hegemony? The answer isn't just about matching SpaceX's technology. It's about achieving strategic autonomy so that the global space economy remains a multipolar competitive market. Technically, the answer is methalox. Liquid methane is the golden fuel. It burns clean, which is essential for rapid reuse without engine overhauls, and it's significantly cheaper than kerosene. Every major player we track, from Blue Origin to Landspace, has pivoted to this architecture. On a global scale, we see distinct strategies. The U.S. leads with operational maturity. China is in a high-speed catch-up phase, driven by aggressive policy. Meanwhile, Europe and India are focused on technical verification to ensure they aren't left behind in the autonomous launch market. One of the most innovative drivers we've seen is in China. The SSE Star Market's Rule 9 feet is a game-changer. By allowing rocket firms to go public based on technical milestones rather than immediate profit, China has successfully unlocked the public capital markets to fund the R&D-intensive RLV race. Landspace's ZHUQUE3 is a prime example of this. By utilizing stainless steel, a strategy popularized by Starship, they are optimizing for durability and low-cost manufacturing. Their success in December 2025 signals that the competitive gap in the methalox era is closing faster than many Western analysts predicted. Don't count out Blue Origin. The successful landing of New Glenn in late 2025 was a pivotal moment. It officially ended the SpaceX monopoly on vertical landing. With their massive heavy lift capacity, Blue Origin is positioned as the primary alternative for large-scale institutional and commercial missions. The benchmark for the industry remains 13 days. That is the time it takes SpaceX to turn a booster around. At HDIN, we argue that reusability is a misnomer. The real metric is reliable recyclability. If you can't relaunch within a month, the economic benefits of reusability begin to evaporate. The RLV flywheel is simple. Recovering the booster leads to massive CapEx savings, which lowers launch prices, which then attracts more satellite startups. This cycle creates a more resilient orbital network and higher demand, further driving down costs through economies of scale. Looking ahead to 2030, we expect a tiered maturity. By 2027, Starship will likely be the backbone of lunar logistics. By 2030, we envision a world where space launch is as routine as a cargo flight across the Atlantic. This is the timeline our clients are building their 10-year strategies around. This matrix highlights the parity we are seeing. While SpaceX set the standard, the ZQ3 and New Glenn are now matching or exceeding Falcon 9's recovery capacity. The industry is converging on a standard architecture: methalox engines and vertical recovery. In conclusion, the RLV is the gateway to the next trillion-dollar economy. We are moving beyond just connectivity to, in-space manufacturing and orbital compute. In this new world, the cost of weight is no longer a barrier. It's an opportunity. We are standing at the gateway. Reusability is the paradigm shift that transforms humanity into a multiplanetary species. The window for strategic entry is now. Thank you for your time. HDIN Research provides bespoke analytics for the aerospace sector. We invite you to reach out for a deeper discussion on how these trends impact your specific portfolio. Let's open the floor for questions.